I'm Ethan Knight with Western Water Assessment here at the University of Colorado Boulder. Thank you for joining us today. In today's webinar, we will learn more about the Snowtography, Snowpack, and Soil Moisture Monitoring Handbook. Western Water Assessment, in collaboration with the Nature Conservancy and the USDA-Agricultural Research Service, has produced Snowtography, Snowpack, and Soil Moisture Monitoring Handbook to support resource managers, researchers, and practitioners studying forest structure impacts on snowpack persistence and soil moisture availability. The handbook guides readers through the process of establishing their own snowtography and soil moisture monitoring stations. It offers guidance on site selection, snowtography options, equipment requirements, and installation. The instructions are based on snow forest research and hands-on experience at multiple sites in Arizona and the San Juan National Forest in southwestern Colorado. The webinar will cover the motivation for developing the handbook, the science supporting the snowtography method, the structure and contents of the handbook, and on-the-ground experiences of handbook beta testers, followed by Q&A. We have 6 speakers today. Sorry if I can get it. Our first speaker is Marcos Robles, who is lead scientist for the Arizona chapter for Nature Conservancy. Trained as an ecosystem scientist, Marcos develops science that helps the Conservancy and key partners advance climate mitigation and adaptation strategies for all of Arizona's ecosystems. Our second speaker is Joel Biederman, who is a research hydrologist with the USDA-Agricultural Research Service in Tucson, Arizona. His work focuses on how changes in climate and land cover affect interactions among water, carbon, and plants. Our third speaker is Liz Payton, who is a water resources specialist with Western Water Assessment. Trained as a water resources engineer, she works with water users in the Western Water Assessment region to access and understand climate and hydrology information. She is also the water chapter lead for the 5th National Climate Assessment. Our fourth speaker is Danny Margoles, who is the coordinator for the Dolores Watershed Resilient Forest Collaborative, a group that works to enhance forest, watershed, and community resilience in Southwest Colorado. Danny has a master's in geography from the University of Minnesota, where he studied the impacts of bark beetle outbreaks on high elevation forests and periodically teaches with the Wild Rockies Field Institute in Montana and Fort Lewis College in Colorado. Our fifth speaker is Lindy Hutchinson, who is a first-year graduate student in the Applied Geospatial Sciences program at Northern Arizona University. Lindy currently works as a teaching assistant for the geography department, as well as with the Rocky Mountain Research Station and Southwest Watershed Research Center at the Snowtography site in the Sierra Ancha Experimental Forest. Our last speaker is Seth Ahrens, who has extensive experience in atmospheric science, biogeochemistry, ecosystem ecology, and snow hydrology, and currently works for Western Water Assessment as a research scientist based in Salt Lake City, Utah. Prior to working with Western Water Assessment, Seth worked for the Utah Division of Air Quality as an environmental scientist, where he worked extensively with air quality and weather instrumentation. Before we get started with the presentations, I want to share a bit about Western Water Assessment for those of you who have not worked with us in the past. Western Water Assessment is an applied research program that addresses societal vulnerabilities to climate variability and climate change, particularly those related to water resources. We are based in Boulder and Salt Lake City and work across the Intermountain West, or Colorado, Utah, and Wyoming. Western Water Assessment is one of 11 teams in the NOAA Regional Integrated Sciences and Assessments, or RISA program. The presentation will be recorded and last about 60 to 70 minutes, followed by Q&A. Please feel free to submit questions via the Q&A window. We'll be sure to share a link to the recording with you once it is up on our website. And I will hand it off to Marcos. Thanks.
Great, I'm just going to share my screen here and do a quick sound check and make sure I'm in presentation mode. I can see my panelists. Is there a thumbs up for audio and presentation mode? Cool. All right, well, and let me just move my screen here so I can navigate. I first want to thank the Western Water Assessment for hosting this webinar and for everyone's time attending. So I have the privilege of starting off the webinar and sharing the perspective of the Nature Conservancy, specifically why we were interested in developing a snowtography handbook and a little bit more detail about the folks you'll hear from today. So with a generous gift from the Walton Family Foundation, we convened a collaborative group of scientists, non-governmental organizations, and forest practitioners to develop this Snowtography Handbook. As a way of a brief introduction, snowtography at its most basic level is taking pictures with remote cameras of graduated snow stakes that are placed across forest gradients, that is shown in this infographic. Snowtography installations that we'll describe today are primarily at the local scale. Some of the estimates we give in terms of costs and labor time are for about 2 transects at 70 meters long. However, snowtography is easily scalable to address questions at larger geographic scales. And it's meant to augment snow data from existing monitoring networks like the SNOWTEL stations that many of you are probably familiar with, run by NRCS, to better understand how the diverse and heterogeneous forest settings across the Colorado River Basin impact snow, soil moisture, and water resources. So the idea for developing the handbook came through discussions within our Colorado River program. The Colorado River program is a collaboration of state chapters of the Nature Conservancy within the Colorado River Basin who seek to improve environmental flows and sustain freshwater ecosystems and the human livelihoods they support in the basin. Of course, we're dealing with a context in the 21st century that's unprecedented as it pertains to forest and water resources within the Colorado River Basin. Multiple studies have shown that there's been about a 20% decline in snowpack and streamflow levels since about the year 2000, with about half of this decline linked and attributed to warmer temperatures caused by human activities. Unfortunately, we've also experienced large scale forest disturbances, catastrophic forest disturbances in the basin and across the West. These disturbances have been made more severe due to drought, a combination of drought, warmer temperatures, and a legacy of forest management that has resulted in overly dense forests in many locations. And perhaps on a more positive note, with the recent passage of the bipartisan infrastructure bill that Congress recently passed, the federal government has now made historic investments in water security and wildfire resilience, including a plan to complete field treatments across 50 million acres in the next 10 years to reduce wildfire risk. So the Nature Conservancy has long worked with forest practitioners to apply ecologically based forest management at large scales in order to achieve multiple objectives. Common denominator in most of these treatments is that they reduce risks of catastrophic wildfire. But within the Colorado River program, we also seek to develop science and monitoring to evaluate where and when forest management can sustain watershed and forest resilience due to the drought and climate change context I just spoke about. And a critical component of our strategy in forests is that we are looking for places where ecologically based forest management can achieve multiple benefits for people and nature, not just benefits for one resource. So we have a companion project going across the West where we are mapping places where ecological forest management can achieve co-benefits to water, fire resilience, carbon, biodiversity, and communities. So with that context, back to the Snowtography Handbook. In Arizona, where I work, we have collaborated with the U.S. Forest Service, the USDA-Agricultural Research Service, the Salt River Project, which is a large utility in our state, and scientists from several universities to use snowtography equipment in conjunction with other monitoring techniques to understand forest management effects on forest and water resources in the Salt and Verde watersheds, which are important economic watersheds for the Phoenix metro area. So with the handbook, our short-term goal was simply to share this experience and knowledge base more broadly with practitioners across the basin. The next speaker, Joel, will speak a little bit more about this, but we are not the inventors of snowtography. I don't want to imply that, and we want to acknowledge others who are also using this technique, but we simply with this handbook wanted to share knowledge with practitioners. As we were developing the handbook, we wanted to learn from it. So we incorporated into the development of the handbook beta test sites where we installed Snowtography installations in new locations. And we use these beta test sites both as a proof of concept that we could expand our knowledge base through the use of this handbook, and also to improve the content of the handbook itself as they helped provide guidance to us on how to make it more user-friendly. And then lastly, our long-term goal within the Colorado River Program and Snowtography is to begin to reach out to the forest practitioners we already have relationships with and others to see if we can develop a network of snowtography monitoring stations across the diverse forest settings within the basin to continue to build our knowledge base and the scientific evidence for forest management effects on water resources. So with that, Ethan gave a quick preview of this, but I just wanted to go through the rundown of who is going to be talking today. From my perspective, this is one of the most interesting projects that I have been a part of just because of the diversity of expertise of each of the participants. So after I finish speaking in a few moments, you'll hear from Joel Biederman from the Agricultural Research Service on what we have learned about the science needs of snowtography, some early results that we've learned from the past 10 or so years in Arizona, and applications of this science. Liz Payton from Western Water Assessment will then walk you through the rich and user-friendly content of the handbook. She was the lead in developing the content. And then we are going to transition and hear from some of the forest practitioners that are the early adopters, as I just mentioned. So Danny will speak about an installation in the San Juan National Forest in Colorado. And Lindy will speak about a similar beta test site that was installed in the Tonto National Forest in Arizona, at a very interesting site, the Sierra Ancha Experimental Forest, where there's also a long history of monitoring climate and flows. And then finally, Seth from Western Water Assessment is going to talk about lessons he learned about installation and equipment tips that will hopefully be useful to practitioners that are interested in this technology. So with that, I will stop sharing my screen and I think hand it over to Joel. Thank you.
Thanks, Marcos. Could I get a thumbs up from a panelist if I can be seen and heard? Great. So Marcos has given us a great introduction to the project and the roles that the various panelists play in it. I'll echo what was said about this being a really interesting project. My role has been primarily to provide background on the science and then field support and logistics. And then I'm involved in ongoing publication in the scientific literature. So this project has been really interesting for me in terms of actually having direct interactions with people who might use this kind of information, and we hope will use the handbook. So I'm going to begin with setting the stage for why we wanted to develop snowtography. And as Marcos said, it's not a new technology. There are snow hydrologists and others who have been taking photos of snow with automated cameras, I'm sure, for decades. But the goal here was to get it documented and put out in a formalized and easy to understand way, which I think Liz has done a great job of. So we've known for a long time that forest structure affects snowpack at the most basic level. Whether snowpack is underneath some forest canopy or out in the open can affect the process of interception, with snow landing in the trees and not reaching the ground. But a lot of field work by Paul Brooks, Ann Nolan, and others I see on this call has documented that the spatial arrangement of forests with respect to snowpack is also really important. So in this photograph taken in northern New Mexico, we have deep snow where the photographer is standing because they're in a clearing and also shaded from the sun, which is behind the photographer by some nearby trees. So the photographer is standing at a cold spot in this clearing. Moving across the clearing to the far edge, there's shallower snow and eventually a warm forest edge where the sun can shine, interception by trees is happening, and also those trees heat up and emit thermal radiation for several meters around them. So it's really important that we understand and predict the consequences that forest structure has for snowpack, including on processes regulating groundwater inputs, stream flow, soil moisture for remaining forest. Marcos mentioned a lot of disturbances, so that's something we're really interested in, is how does that affect soil moisture for remaining forest, and then the strong linkage that's been demonstrated between snowpack processes, the amount and timing of snowmelt, and then fuels moisture regulating fire risk. So forests are changing rapidly. Marcos also mentioned this. In the top image shows a pretty common scene across the highlands of Arizona and many parts of the West where fire exclusion has been successful for the last 120 years or more. And those forests are often changing either by human hands, like the thinning operation shown in the lower left, or by nature through wildfire, pests and pathogens, and drought mortality. So it's important that we understand that many decisions that are made about forests and their effects on snowpack and the downstream consequences I've listed again here are made with models. So a typical model scale for a forest hydrology model might be 30 or 90 or more meters across. And the cartoon I've drawn here illustrates an important thing to know about these models. Many times they represent aspects of the forest like the height and the percent cover with a single number for each model tile. But the field research that I've talked about has illustrated that it's really important to understand how that forest cover is distributed. What's the structure within the tile? So I've just shown 3 different ways here that we could distribute 30% forest cover, but these might have very different impacts on the amount and timing of snowmelt. So in some nice work by Ryan Currier and Jessica Lundquist a few years ago and ongoing, they've been looking at this. So using high resolution spatial maps of snow depth and forest, and then looking at the scale of a model tile, say the black box here represents 90 meters across, and then this cartoon from their 2018 paper illustrates a model tile with 40% forest, 30% is exposed in a clearing, but then critically, this warm south-facing forest edge represented here in red, or a cool north-facing forest edge represented in blue, and then the bar graph below shows how those different areas actually accumulate peak snowpack. So this metric SWE, as many of you know, stands for snow water equivalent. That's the liquid equivalent of the water that you would have if you melted the snow. So another motivation for snowtography, and in general representing and understanding the snow processes that are affected by forest structure and interactions with weather and topography, is to inform decision making. Things like whether we would conduct a thinning operation in level terrain or on a north aspect or on a south aspect. Small differences in aspect can have major impacts on snow retention, as shown here with these relatively gentle slopes following a thinning operation at Mount Bigelow near my office here in Tucson. So we have many excellent observations of snowpack. Many of them are publicly available. We have remote sensing data sets, which can take large spatially continuous maps, often every few days or few weeks. Usually those are not at the spatial resolution necessary to resolve individual trees, but that's changing rapidly in recent years. Other kinds of important snapshot information include Lidar Mapping. That stands for light detection and ranging. Basically, lasers are shot from airplanes at bare ground during the summer. Then the plane returns during the winter, shoots a laser again at the snow. And the difference in the time that it takes to return to the plane can be related with high accuracy to the snow depth. The image shown here in the lower left is a different kind of snapshot. This is taken from an unmanned aerial vehicle, or a UAV, also called a drone. This is from Adam Belmonte's work at Northern Arizona University, looking at snow persistence following thinning operations. We can see the consequences of many of those cool edges retaining snow longer than other places in the image. A different kind of important information is temporally continuous information. This is often important if we want to train a model. Having a snapshot is really powerful, but having daily or even hourly observations can be really important for training a model to represent processes. So the most common type of point information, Marcos mentioned the NRCS SNOTEL, and there are other similar networks, can give us hourly or daily observations of snow depth and the snow water equivalent, and often some nearby related meteorological information. What I've illustrated here in this graph from Patrick Broxton's 2019 paper, though, is that snowtells are often located in sheltered clearings, and they're known to overestimate broadly the snow distribution across the landscape. So in black, I've shown the snowtell, and then we've shown in these colored bands different classes of the landscape. These correspond directly to those from Currier and Lundquist's paper. The open areas, cool and warm edges, and then under canopy, we can see there are major differences, and we represent them here at the daily scale throughout the winter. So snowtography, we think, can address a lot of these issues. At its most basic, snowtography is daily snow depth recorded by cameras, as shown here. If a user is willing to visit the site maybe once a week or every 2 weeks, or every time after a major snowstorm, and take density measurements directly, we can also develop a fairly good time series of the snow water equivalent. Additional upgrades might include soil moisture sensors, which can be automated to collect data remotely, and it can show up in an app on your mobile device. Soil moisture is critical to many of our stakeholders because it's predictive of snowmelt, snowmelt-driven stream flow, and critical for forest health. So we have a growing network of 6 stations with which I'm involved. I'm sure there are others. The most 2 recent that Danny will talk about and Seth will talk about, the one here in Southwest Colorado in the Dolores, and then the site with which Lindy's involved with her research is in the Sierra Ancha Experimental Forest here in Arizona. And these other 4 sites are 3 to 6 years old now. They were developed in collaboration with the University of Arizona Remote Sensing Center and with funding from the Salt River Project. So here on the left, I've illustrated what I think is one of the interesting sites. This is a forest thinning site near Flagstaff, Arizona. With TNC funding, portions of this site were thinned with different geometric arrangements, so allowing us to really look at how differing forest structure affects the snowpack and the soil moisture. These red dots illustrate the locations of snowtography sticks, and those have been placed north-south to capture variability related to shading, and then also east-west for variability related to the predominant wind direction. So the last part of my portion of this talk will be about some applications. And I would encourage those of you watching to jot down your notes about whether these applications are of interest to you, and also suggest your ideas, what your particular needs might dictate at your site. So first, a straightforward but very valuable application has been real-time monitoring. We have paid about $30 extra per camera for a few cameras at each site to have a cell modem built in. You can pick your network, so if your site has any kind of cell coverage, 1 bar is enough. You can relay a few images a day, and this has given us the capacity to decide when to visit a site to take density measurements or other kind of measurements, help us time snow surveys, and also this is growingly used for water resources prediction by some of our stakeholders. The panel on the left here I've shown before. This is a mid-elevation ponderosa pine site where the snow is somewhat ephemeral. This is of growing interest in many places in the Colorado River Basin, especially the lower elevations. As temperatures warm, it's becoming increasingly common to have ephemeral snowpack sites. So understanding how the different categories with regard to forest structure shown in the colors relate to the snowtell and the broader watershed at this mid-elevation site, it's much different from how they relate at the higher elevation site, where those forest structural elements have a much bigger impact on snow. In this application, we looked in detail every day for 2 weeks following one of the largest snowstorms that we'd observed at this site here south of Flagstaff, Arizona. There were about 4 feet of snow, resulting in more than 15 centimeters of snow water equivalent, liquid water equivalent. And we followed this using a snowtography transect that was 80 meters long, shown here at the bottom, from a thinned forest where a private landholder had proactively thinned around their residence through a transition zone. This is a cold edge, it's north facing, into an unthinned forest. And this red curve shows the snow water equivalent immediately following the day after the snowstorm. And we see pretty much what we'd expect. A little bit less snow lands in the unthinned forest because primarily of interception. But 2 weeks later, most of the snow that was in the forest has ablated. Almost all of the snow that was in the clearing, in the thin forest has ablated, but 80% of the snow was retained in that cool north-facing edge that's labeled transition zone here. Having this kind of information spatially distributed, but also at the daily timescale, is really critical for training a model to understand and predict the effects of forest thinning at these sites. I mentioned earlier that an optional upgrade includes soil moisture. What we're primarily interested in here is how time series of snow water equivalent, shown in the top panel, set up the soil moisture moving in out of the snow melt season and into the early part of the summer, where in many parts of the Southwest, there's very little precipitation until the arrival of the North American monsoon, sometime usually in July. So understanding how forest structure impacts the snow, and then that translates downstream to soil moisture. And then the last two applications I'll show are for some nearing submission work by a postdoc in our group, Ravindra Dwivedi. And what I'm showing here on this slide is how Ravindra has used snowtography observations to train a model of canopy snow interception and storage. For those of you interested in that kind of thing, this is the listed and elder parameterization. So the panel on the left, Ravindra basically evaluated the radius of influence that canopy has on interception with snowtography stakes at larger and larger radii away from a canopy, and found that at a mid-elevation ephemeral site, it's only a couple of meters where the model and the data match most closely, and that the high elevation colder site, it's 8 meters. So that's really valuable for understanding snow processes at these sites. Here on the right, Keng-Sun Lee, a graduate student at the Arizona Remote Sensing Center at the University of Arizona, working with Wim van Leeuwen, evaluated just in this general classification how much snow is in the canopy. He wrote down a lot, some, or none, and then we've used that information to further train a canopy snow storage model, which is really important for predicting how much snow sublimates or drips or drifts onto the snow. And then the final application here, also from Ravindra's work, compared with increasing forest cover fraction. Each one of these dots is a snowtography stake. They're only a few dollars each, so we deployed a lot of them across gradients of forest structure at the high and mid elevation site. And this work shows how forest cover reduces the net water input to soil, that's combined snowmelt and rain, more strongly at a high seasonal snowpack site than it does at the lower elevation ephemeral snowpack site. So in summary, snow amount and snowmelt timing are definitely affected by forests. Training the models that we use to predict these effects requires frequent snow measurements at the spatial resolution of the trees. Snowtography provides such measurements with daily snow depth and canopy storage. Optionally, we can develop time series of snow water equivalent and soil moisture. I've shown a few of the many applications for forestry and hydrology, and I'd be very interested to know, either in the panel discussion to follow, or feel free to email me about what needs there are from stakeholders on this webinar. And with that, I will turn it over to Liz Payton at Western Water Assessment to talk about what she's done in developing and leading the Snowtography Handbook.
Thanks, Joel. There we go. So hopefully you can see my slides okay. I see a thumbs up, thanks. As Marcos and Joel have mentioned, the handbook guides readers through setting up 3 levels of snow monitoring. Basic snowtography, which is a system of automated trail cameras and graduated snow stakes arranged in transects to monitor snow depth. Snowtography with periodic site visits and a snow sampler to measure snow density and snow water equivalent. and snowtography with soil moisture sensors and data loggers to monitor soil moisture status. Our goal in developing the handbook was to guide users through the process of establishing their own snowtography and soil moisture monitoring stations. And I don't expect you to read all the tiny words on any of these slides. Just consider them as illustrations from the handbook. They're excerpts of pages. The image on this slide on the right is an excerpt from a page showing a list of supplies to bring to the field when planning a snowtography site layout. With lots of input from the beta testers and other contributors, we wrote the handbook as a how-to manual with icons, illustrations, and photos to support the step-by-step text. The beta testers worked with draft sections of the handbook and gave us extremely valuable feedback that helped us refine the text to be more useful and accurate to conditions on the ground. The handbook is organized in a progression from high-level planning through detailed on-the-ground installation. I'll briefly walk us through those sections now. After the introduction section of the handbook dives into planning, including selecting a site. It covers the factors you'll consider when selecting a site for a snowtography question. It asks, what are your research questions? What are your information needs? Where is there a transition in the variable you want to study? Can you find a site that helps you avoid the confounding effects of other variables? For example, if you are interested in snow accumulation in thin versus unthinned areas, you may want to avoid choosing a site that spans both north and south-facing slopes. Planning also involves estimating your costs in terms of time and funds. The handbook provides an estimated range of equipment costs and person hours for each of the monitoring options. Planning a snowtography station can be an iterative process, especially on a limited budget or with limited personnel. The area that you want to cover will determine the total cost and labor required. Time-lapse trail cameras and soil moisture monitoring equipment are limited in how much area they can cover. Larger areas will require more cameras and soil moisture sensors and data loggers. Larger areas will require more snow stakes too. The materials for snow stakes are relatively inexpensive, and there are economies of scale, but they require quite a bit of time to repair. After helping readers select a good site location, the handbook provides guidance on planning the site layout. A good layout will position the equipment in the best locations to capture clear observations across a transition from one landscape variable state to another. The handbook provides instructions for designing the snow stake transects, choosing camera locations, and selecting soil moisture sensor locations and depths. After the planning sections, there are 3 sections devoted to the specifics of setting up the 3 monitoring options, including itemizing the supplies you'll need and listing the directions step by step. These handbook page excerpts are here to illustrate the level of instructional detail that the handbook contains. I hope you can't hear somebody's leaving a message on my phone. Sorry about that if that's messing things up for you. Snowtography and soil moisture monitoring setups benefit from advanced preparation in a lab or garage, where you can test the equipment and paint snow stakes under controlled conditions. We don't have enough time to go into all the pages and pages of details provided in these sections. I'll just say that a great deal of thought and experience went into these instructions, and they will help you to avoid many errors and pitfalls if you follow them. The handbook also supplies information about testing and equipment before going to the field and after installation. The time-lapse trail cameras can be programmed and their range tested at home. Soil moisture sensors can be run through wet and dry soil tests at home. The handbook describes methods to test equipment in the field as well. In this picture, Danny Margoles is checking photos from a trail camera that he has just installed to make sure that it is photographing the snow stakes adequately. At the end of the season, or more frequently, Photos from the trail cameras are downloaded from modem-enabled cameras or taken off the camera's SD cards. And daily snow depths are visually determined and entered into a spreadsheet. The figure in the upper right shows snow depths from the Snowtography transect in the inset photo. Snow density data are hand recorded as they are collected in the field. Soil moisture data are downloaded. The figure on the lower right shows daily soil moisture data. The last group of handbook sections includes one containing troubleshooting tips, with marmots and other fauna often being culprits, and one describing applications of snowtography like those that Joel discussed, followed by a brief list of references. We encourage readers to be resourceful. The handbook can't cover all landscape and soil types, potential climatic conditions, or equipment innovations. Of course, we would love to hear from you if you have feedback about our instructions or have some ideas of better ways to do things. With that, I will hand it off to our fantastic handbook beta testers, starting with Danny Margoles.
Thank you, Liz. I'm gonna share my screen. Once I'm able to. Okay, does that look right? Awesome. Well, welcome everyone. I am Danny Margoles. I am the coordinator for the Dolores Watershed Resilient Forest Collaborative, also known as DWARF. DWARF is a diverse forest and watershed health collaborative working in Southwest Colorado, but I want to specifically highlight a number of partners here who have been really instrumental in getting this project, this monitoring off the ground for us. That's the Dolores Water Conservancy District, a few different individuals at Fort Lewis College, a few individuals at Mountain Studies Institute, folks with Trout Unlimited, the Dolores River Anglers chapter here, and the San Juan National Forest. So what I want to do today is go over a little bit of background on the collaborative and the collaborative work happening in Southwest Colorado here, why we found it valuable to participate as a beta test site, our planning steps and approach. Just want to mention the timing of the installation and just show a little bit of the initial data to all of you. So as context, and as I mentioned, DWARF is a diverse collaborative group working in the southwest corner of the state. We focus broadly on forest, watershed, and community resilience. And while our focus spans different forest types and multiple large watersheds like the Dolores and the Mancos watershed, most of our main conversations recently have spanned and have focused on the Ponderosa Pine Zone and associated wildland-urban interface. The Ponderosa Pine Zone, as Marcos mentioned and other folks have mentioned, is where a lot of restoration is often needed right now and is closer to our communities and has seen a lot of impact from like just land management legacies. So over the past few years, DWARF has engaged in discussion around the scope and potential outcomes of multiple large-scale forest management projects in the area, the Ponderosa Pine Zone, and all about 85,000 acres have recently been cleared through NEPA for implementation. Some of the implementation has begun, kind of identifying that orange blob on the map. And it's a number of different contracts, from commercial contracts to stewardship contracts. So last summer, the manager of the Dolores Water Conservancy District that manages McPhee Reservoir, a major reservoir in Colorado here, contacted me to see if being a beta test site is something that DWARF would be interested in. He thought so. He was contacted with the other partners on the call here, and I thought that it was totally in line with our vision, brought it to our larger stakeholder group, and they similarly thought that it was a really great opportunity for the group. This happened last summer. Conversations started happening last summer. We had kind of an approach developed by the end of summer, and installation began in October, and our second transect got finished in November. So all in all, it happened pretty rapidly. And just want to highlight that if folks are interested in this, and you have some dedicated individuals really wanting to dig into it, you can pull it off pretty quickly. And I also just want to highlight that there are multiple collaborative groups operating across Southwest Colorado with a relatively similar scope to Dwarf. And spanning where these collaboratives are working are some larger forest restoration and resilience initiatives that are beginning and underway right now, including the Collaborative Forest Landscape Restoration Program that we just got kind of accepted and are beginning governance conversations for right now, and the Rocky Mountain Restoration Initiative. And all in all, what this means is that there's more work going to be happening in Southwest Colorado, especially in the Ponderosa Pine Zone. And there's going to be a major focus on monitoring and learning from the outcomes of management and adjusting and adapting as needed to meet desired conditions and future conditions. So for the beta test site itself for Dwarf, we just started digging into like, what do we want to look at with this? What do we want to learn from a test site here? Being a diverse collaborative, there are different folks that are really focused on different areas. And from conversations, we identify kind of two core areas: water quantity and forest structure influences on moisture availability. As folks have already kind of hit earlier in this webinar, the water quantity question is difficult, and it's kind of a bigger scope than especially what this beta test site is. And I think that, ideally it could be a longer range objective for this monitoring, but right now, and especially where our current conversations were, we decided to dig into kind of how forest structure influences moisture availability in our landscape. So our primary question was, how does canopy cover influence snow and soil moisture? And what we decided to test was a thin to unthin transition in canopy cover at a Ponderosa pine site called Chicken Creek in Southwest Colorado. In order to do that, we also identified a number of other variables that we wanted to control for. I want to say thank you, Seth, or thank you especially Joel and other folks locally here, Mike Remke especially, for helping to identify these kind of controls. So we were controlling for a treatment type. There are a few different treatment types that happen in the area. It was a thinning project with large machinery, but it was also close to an area that had mastication occurring and different kind of time eras of treatment. So we controlled for treatment type. Understory cover, especially Gamble oak, can be highly variable and probably influence snow and soil moisture, and we tried to control for that. Control for elevation and aspect. Aspect was initially going to be kind of a secondary test that we wanted to look at, but the more we looked, the more we just identified like most of the area is southwest facing, kind of going downhill to the southwest. And if we make sure to hit a site that has that, multiple sites that have that, we're going to be answering some good questions there. We chose a site at Chicken Creek for a few reasons. Again, as I mentioned earlier, there was recent thinning work that happened. These specific treatments and that treatment area has been a focus of collaborative conversations. It's a high use and high visibility recreation area, and saw a lot of benefit in focusing our research and learning and ongoing conversations in an area that we've already been having discussions in as a collaborative, and just like deepening our knowledge of that specific site. It has relatively easy access, both driving and also it's a Nordic ski area, and has relatively access in the winter for us to get out to the location. There's cell phone reception there, and we were, just due to partnerships, able to install at that site pretty rapidly on short order. And thanks to the San Juan National Forest for facilitating the monitoring permit pretty quickly. For the layout, we explicitly chose not to do random site selection. We wanted to test a thin to unthin transition. And so we intentionally selected kind of the extremes, like an area that was like totally thinned and had lower canopy cover, as well as an area that had higher density trees, higher canopy cover, and chose sites based on that. We scouted camera locations early on to make sure that it would work with the cameras, and we'd be able to see the stakes with the cameras where the trees are located, and put horizontal transects at the extremes of the transects that you can see here. So we wanted to add a number of data points, essentially, at the extreme of thin, the extreme of unthin, and at that transition zone that Joel was talking about earlier. And we put the data logger at the transition and extended the soil moisture sensors into the thinned area and the unthinned area from there. So again, we had two transects, one where we get in the transition zone some shading from trees, so kind of a northern one, and then a southern transect where we don't get that same shading. 12 cameras split between those two different transects with 2 images per day being taken. Snow density measurements, we're really trying to do twice per month to get ultimately snow water equivalent there. And timing those kind of based on when snow events are happening. So right after a snow event, we are going to be trying to go out to take those density measurements to see the differences along the gradient, and then 5 to 7 days or so after that initial measurement to see how the ablation process might be affecting the gradient. And then the soil moisture sensors, 6 at each transect, which is the maximum number that can be put into the data loggers. So some initial photos. This is from December. And what I just want folks to see here, hopefully it works to go through these photos. It didn't really work on a test run earlier, but I want everyone to just look at that first stake. This is over a 7-day span. And just looking at snow accumulation and ablation, and looking at like those inch increments there, and how the ablation kind of, starts happening. So. Hopefully everyone can see that I'm panning through. So on the 10th, there was a snow event, and then the slow melting that's occurring throughout the rest of the days. And what I want to highlight is we haven't started working up all of the images yet, and we're developing kind of a process with our local partners to do it and try to ideally find some funding for folks. We don't really have the funding to go through that yet. And either work through partners with Fort Lewis College to have some students help us process it, or just through our other partners here. So I guess there was one more. And then some initial data of snow depth and snow water equivalent. While these are early results with relatively few points, I think the results are pretty interesting and seem to support some of the patterns that Joel was highlighting earlier, especially that higher depths and snow water equivalent along the shaded transition zone. So where you see the north areas up here along the north transition. But I'm excited with our partners to keep digging into that. I wasn't able to yet pull together some of the soil moisture data, but our group has been encouraged that the readings have been relatively constant and not jumping around too much, and have been responding to moisture events. And what those differences are, we haven't looked at yet, but we're excited to do so. And we'll be continuing to report out through I'm sure different networks. I just want to thank the dwarf stakeholders and partners that have volunteered their time and energy and expertise into this. I want to highlight that I'm not a hydrologist and a snow snow expert by any means, but we do have folks down here that are the experts that have made it entirely possible to do this project. And I also want to thank Joel and Seth and Liz and Marcos, especially, and the others involved here, for allowing us to have this opportunity and to giving us these resources. And yeah, much appreciation. And now I want to pass it off to Lindy Hutchinson with NAU to talk about the other beta test site down in Arizona.
Thanks, Danny. All right. My name is Lindy Hutchinson, and I am a first-year graduate student in the Applied Geospatial Sciences program at Northern Arizona University. I'm working in collaboration with the Rocky Mountain Research Station and Southwest Watershed Research Center at a recently installed snowtography site known as the Workman Creek site. And it's located in the Sierra Ancha Experimental Forest in central Arizona within the Tonto National Forest. And this beta test site was recently installed in November of 2021. So here's some photos of the site area that I took during installation. And at the site, we have two transects running north to south, both 85 meters in distance. And the transects go from a forested area crossing into a cool edge transition zone, and then into an open area that is a 20-year-old burn scar. So this site was affected by a high severity wildfire in the year 2000. The experimental forest is managed by the Forest Service, and research in the area is focused on watershed management. So historical data sets exist in this area. I'm monitoring related to water flow and snow depth, and our intentions are to add to those data sets by monitoring snow and soil moisture through the use of this snowtography site. Information on preparation involved for a snowtography site can be found in section 4 of the Snowtography Handbook. You will need the necessary supplies listed, including cameras, snow stakes, posts, and any tools and equipment for installation. Additionally, soil moisture sensors and data loggers if you're choosing to add soil monitoring as a component to your site. You want to make sure that you secure all of your testing equipment and have a game plan before entering the field. Can't emphasize enough the importance of making sure your equipment works before getting out in the field and that you are familiar with it. And as far as preparation, the main process that I was involved in for this site was the snow stake preparation. This was also the most time-consuming part, so I'm going to share some insight about prepping snow stakes. So the steps are laid down clearly in the handbook on page 28. But as far as preparing the snow stakes, you are laying out all the boards, marking the boards with a 1-inch increment scale, and laying down tape across those boards, masking off every other row. So you can then paint the scale and finally stain it with a lacquer. But some things to consider when you're preparing snow stakes is your workspace selection and the time involved, whether you will be working indoors or outdoors. I personally worked indoors, and I found that this was helpful because I had a lot of snow stakes to prepare. I had around 100, and it proved to be pretty time consuming. So working indoors allowed me to just go at my own pace and chip away the steps over a couple weeks when my time allowed. If you are working outdoors, you will probably need to move through this process much faster. and take into consideration weather. Also keep in mind the drying time. So there's numerous steps that involve paint. So you're adding on a couple of extra days when you are preparing the snow stakes. And lastly, bulk painting is an option. So I would recommend starting off smaller, trying maybe 10 to 15 boards and going through that process. You risk accuracy when you add more boards if you're trying to bulk paint and move through these steps. So I wanted to share some of the lessons that I learned the hard way, and hopefully this will save you some time and aid in the process. So as far as marking off the scales on the boards, you're marking every inch from the bottom to the top of the board. And I experimented in bulk painting, just marking the ends of the boards and then trying to stretch the tape across and match those marks. I found that this didn't work too well because there weren't marks in the center of those boards to guide the placement of the tape. Eventually, I ended up marking almost every single board with the scale. So I had marks to guide down the tape. That's the type A personality in me. So maybe you don't need to mark every board like I did, but I'd recommend marking at least every couple of boards or every other board. So you can just improve your accuracy for when you are creating these snow stakes. And as far as tape, I ran into some issues as well. So I used Gorilla Tape, which has a strong adhesive. And when I peeled off the tape in the final steps, I learned that the tape removed the paint in many areas, or it even peeled off pieces of the board. So maybe it's worth considering trying a less adhesive tape. Although I do want to mention that when you select your tape, make sure it is in fact 1 inch wide. A lot of tapes will be labeled 1 inch, but it might be slightly under or over that measurement. So make sure you are selecting 1 inch tape. And then I also encountered some issues just with the quality of the boards. So naturally, you're going to have some boards that are going to be warped, or the roughness of that surface might vary. And I learned that warped boards, even if they're slightly warped, they weren't conducive for bulk painting. So I would consider separating those boards into smaller groups, or painting them just as a single board, or not even including the more warped boards. You will run into issues when laying down tape if the boards are slightly warped. And then some of the boards that I painted had a slightly rougher surface, and this allowed the paint to bleed underneath the tape, and it left a pretty scratchy, uneven line in the final product. And these photos that I've included are just displaying those issues that I encountered. So the photo on the left shows how the lines and the marks came out if the boards weren't smooth. And it also shows some areas where the paint or the wood was peeled off when I removed the tape. And then the photos on the right can just show how the tape is affected if your boards are slightly warped. So hopefully that will save you a little bit of a headache if you do end up installing a snowtography site. And that's all that I have for you guys. So with that, I will be handing it off to Seth at Western Water Assessment.
Thanks, Lindy. My name is Seth Ahrens. I work with Western Water Assessment based in Salt Lake City. My role in this project was beta testing the handbook through all the way through the stages of procuring equipment to testing that equipment in the lab prior to going into the field and actually going out and setting up a site. I worked with Danny at setting up the Chicken Creek site in southwestern Colorado. I want to point out that all of the things that I'm talking about, these lessons learned, challenges that I faced, all of these things are represented in the handbook. A major goal of this beta testing was to take a very good draft of the handbook and actually test it out in the field and see where there needs to be additional instructions, where there might be some problems. So all of these issues I bring up have been accounted for in the handbook. I just want to share some of these stories because I think some of them will help you in the field. You may encounter some of these same problems. The first lesson that we learned is a very obvious one and one we try to avoid, but it is in fact best to install the site before it snows. Unfortunately, we did not have that luck on our side this year. We were trying to get lots of people together with challenging schedules, and we came up with one date in October that worked, and it just so happened that it snowed the night before. So on our field day, we had about 3 or 4 inches of snow on the ground. Temperatures were in the 20s when we started off. Another thing that this highlighted was not just access to your site during winter. Many sites you might choose don't have access in the winter, but also what's your access in the shoulder seasons. At this particular site, there is a road that goes nearly to the site. However, it's a lesser used Forest Service road that was recently graded and gets very muddy when it's wet. So we weren't able to use the road. Consequently, we had to haul all of our gear in about 3/4 of a mile. Fortunately, we had lots of volunteers and help, so it wasn't too big of a deal. But pay attention to those aspects of access as well. The first category of things I'd like to talk about with equipment is camera selection. So this was something I kind of had the assumption in the beginning would be quite easy. It turned out to be a little bit more of a challenge than I expected. Starting off with the cameras that Joel Biederman's group had previously used had been discontinued by the manufacturer. So in searching for cameras, there's literally hundreds of options. These cameras are typically called game cameras. They're used by hunters. They're motion sensor activated cameras that are often set up in the forest to capture wildlife as it goes by. Some of these cameras have a time-lapse function, some of them do not. A time-lapse function is really the key specification of these cameras that you need. Another thing that was challenging is that unlike scientific equipment, which typically has really detailed specifications, images of the actual devices, you can really get a sense of what the equipment is prior to purchasing. A lot of these cameras don't have very good specifications. So that made it a little bit challenging to pick the camera. And consequently, one aspect of the cameras I chose made it difficult to install the cameras, or at least to take initial setup pictures of where the image was in relation to snow stakes. The display screen and the control panel was inside the camera, so that the camera opens like a book, which is probably common to many of these cameras, but specifically you couldn't open the camera easily while it was actually mounted to the tree mount. And this proved to be a little bit of a challenge. In testing the cameras, this is extremely important. I found that not all of the cameras I purchased, even though they were the same model, same company, worked identically. So I tested the time-lapse function and ended up having to test it for a much longer period of time than I expected. Upon setting up the cameras to exactly the same settings, to have it take pictures at the same time with the same interval between pictures, I found that the cameras performed very differently. So I'd set the time for to have a picture taken at noontime, and it would take it somewhere between 10 o'clock and 2 p.m. So I had to test the cameras multiple times to understand where they were working consistently, where they weren't. Something to keep in mind if you do encounter problems like this. The goal with taking 2 pictures each day is simply to capture 2 different light levels, different sun angles, so that you can see the snow stake well. So it doesn't matter if you take a picture at exactly 10 a.m. and exactly 3 p.m. You just need 2 pictures under 2 different light conditions. Prior to going in the field, I tested all the soil moisture equipment. This is very important, especially if this is being set up by folks who aren't necessarily familiar with using data loggers and soil moisture sensors. I set these up just in my own backyard outside so that the solar panel and batteries could be tested. In order to test the soil moisture sensors, I just used little disposable seedling containers for plants, put some soil in there, added water, and watched to see how the moisture changed over time. It's really important to understand and be able to properly download data. If you're using a cell modem to transmit these data remotely, you want to make sure that you can do that properly before you head out in the field. The final thing about cameras I wanted to mention, and this goes back to the style of the camera, that it was the display and the control panel for the camera was located inside the camera, which is important to keep it waterproof. But with this particular camera, I couldn't look at the view screen or access the control panels when it was like screwed in and mounted to the tree mount. So I would have to kind of eyeball it the best I could, unscrew the camera, and then set the camera in my approximation of the right position, then take a picture to see how that worked out. So it was a little bit of a challenge. There were a few extra steps there. Another thing that I found in the field that I wasn't expecting is I tested to see if the lock fit through the hole on the camera body to lock it to the tree, but I did not test every single camera. Well, it turned out there was some variance in the size of the holes that the lock would go through on the camera body. So I had to kind of carve out some of these holes with a knife in the field. This might be something you want to check out before you head out into the field. The final piece of challenges that we found out in the field, and this was somewhat having to do with the specific weather conditions, that the temperatures were in the upper 20s to low 30s, was dealing with the flexible PVC piping that was used to protect the soil sensor cables. Well, it turns out that flexible PVC piping at 25 degrees, not that flexible at all. It comes in coils and boxes, and that was how I brought it into the field. And we literally had to play a game of tug of war to try and stretch out this PVC piping. And in the end, we actually weren't able to install all of the sensors with really long runs of cable. We had to just make do without putting in this flexible PVC piping. The sensor cables themselves are waterproof, but Joel's group's experience was that animals sometimes chew through these. So this really proved to be a challenge. I know we mentioned in the handbook that you should do this indoors beforehand. I would really recommend doing that. Certainly if the temperatures are going to be cold, and even if they're not going to be cold, this was a more time-consuming process than I expected. The final bit of information about this step of field work I wanted to bring up was you want to plan out how your runs are laid out very carefully. We found some difficulties when we had long areas of slack at the end, at the data logger end of the soil moisture sensor cable, and that we had to find ways to loop this cold, not very flexible PVC piping around the T-post that we used. So you want to try and plan out the best you can to put soil pits in places where you're using as much of that sensor cable length as possible. The final thing I wanted to mention was that the handbook does not include a specific equipment list, as in where can you get some of this equipment, what brands they are. On the Nature Conservancy's website, they have an equipment list that gives potential vendors for all of these different equipment that you will need. I'm sure that Marcos or someone else will share that link. And with that, I'd like to pass it back to Ethan Knight, and he will be leading a question and answer session.
Great, thanks so much, everybody, for your presentations. Heather, if you don't mind sharing the Q&A slide for me. Okay. Great, and Heather, it's in the regular mode.
Yep, I'm working on it. Sorry, my computer's just running real slow.
Oh, sorry.
There you go. It should be in presentation mode now.
There we go. Yeah, sorry. It's taking a little bit. Well, thanks again, everybody, for your presentations, and thanks to all of you who have submitted questions so far. Just remember, if you want to continue sending questions, to put them in the Q&A box. It should be at the bottom of your screen. But for now, I will start reading the questions from the chat. And if you have any more questions that you'd like to send us separately or after this webinar, you can just email us at any of the emails on the slide or at wwa@colorado.edu. And with that, I'll start the Q&A. Danny, I think this was during your presentation, but I think it's open for the group. What soil moisture sensors were you using, and are you masking for frozen soil?
I'd like to actually pitch that to Seth first, of like some of the technical details of the soil moisture sensors, of like which ones we're using.
Yes, absolutely. And you know what? I'm gonna punt that to Joel, because I am forgetting the name of the company that made the soil moisture sensors.
I think it's Zentra.
Zentra,
sure.
thank you.
Yeah.
We're using Zentra Teros soil sensors, and the data logger system that they have is a really easy, user-friendly data logger system. I've used lots of data loggers over the years, met many data loggers for scientific applications. You need to program, and you need some sort of programming language. These data loggers are basically plug and play. It just has like a headphone jack style plug, and you plug that sensor in, and then you can set it up and get it going, and kind of like just drop down tabs on the software. They're very easy to use.
And we really haven't been like analyzing any of the soil moisture data yet. And so, masking for frozen soil, I don't know. I'm going to be, honestly, as I kind of mentioned earlier, I'm going to be relying on some of our other partners who are kind of more specialists in this to help look at that data. And I know that they're actually on the line right now, and I can't like call them. I would be calling on them to answer that question right now if I could, but maybe someone else on the line, like Joel, has a better answer for that.
Sure, I can add a few refinements. Some of the existing research sites, we used Campbell CS655 sensors. They have a 12-centimeter long TDR design, so two long tines like a fork. One of the reasons we used those is labor was limited when we were first doing this, and we found that we could push them in from the soil surface to get some initial, integrated measurements of the top 10 or 12 centimeters of soil. They also offer onboard temperature, so in terms of masking for frozen soils, we can use temperature and instability in the soil water content data to do that. Frozen soils are relatively rare at most of the sites that we have existing, but that's a great reminder to keep in mind, supporting the growing network of users with more common frozen soils. More recently, we're recommending that stakeholders who are not kind of university or agency researchers would use the more user-friendly Meter Corporation setup. That's the one that's been used at the 2 beta testing sites that Lindy and Danny and Seth have mentioned, with the Zentra loggers and the Teros 10 or 11 sensors. And at one site we have Teros 21. So for those of you interested in that, that's soil water potential. So rather than just the volumetric water content, that's an estimate of how hard a tree root would have to suck to extract water from the soil. So that's really important from an ecological context.
All right, great. Thank you, you three. So the next question, Danny, how will this information be used by Dwarf? How do you think it will change where and how you undertake forest thinning treatments?
Yeah, that's a good question. I think that I probably didn't dive into that quite as much as I had intended to. One of the big questions of the collaboratives is how does forest structure impact water availability, and what might that mean for future forests. And right now, this is, we know that this specific monitoring project isn't going to answer all of our questions that we have about future forests, but it's going to help understand conditions for seedlings in the future. And in a warmer, drier climate, how do changes in forest structure along a gradient influence available moisture for trees? And I think that that's like one of the biggest points. I'm not going to, I think that is going to inform how the collaborative engages in discussions around forest management projects and makes recommendations, and then also identifies needs for future monitoring too, for follow-up, to keep understanding how treatments and just how site characteristics themselves influence available moisture and the long-term resiliency of forests to a drier climate, to things like beetle outbreaks, fire, things like that.
All right, great. Thank you, Danny. The next question is the reason for using a DIY stake to save money? Did you consider using a staff gauge? Sounds like a lot of time needed to prep the boards per Lindy's experience, which would suggest that a staff gauge is not a bad investment. Your thoughts?
I would say if you can afford it, yes. And yes, the question's correct. The main reason to use homemade boards was to save money.
All right, great. Let's see. So the next question, have you thought about incorporating work or utilizing citizen science for CocoRa's to collect additional data, or private businesses such as ski resorts?
Yes, the ski resorts had occurred to us. I think that Seth contributed that idea a while back. CocoRa's network I hadn't considered, but we would definitely like to. I mean, one of the main intentions of making this handbook is that as people come up with those ideas of who might be interested, we can point them to the link and they can download the handbook and do this for themselves. So I'll definitely write those down.
All right. Let's see, sorry, some stuff coming in. This next one is, participants can't copy and paste links out of the chat. Is there a way to distribute links? You should be able to actually distribute the links within the chat. You probably can't in the Q&A box, but you can in the chat. I apologize if you can't, maybe there's a software issue or something. Otherwise, you can email any of us on the contact slide if you wanted for us to distribute those links to the audience. I don't see any more in the Q&A box right now. Do any of the rest of you see any more in the chat? I do not.
The only thing I've received some people just asking if a recording of this is going to be available for folks afterward.
Yes, yeah. So usually takes about an hour or so for Zoom to upload the recording to the cloud, and then we put it on our YouTube channel. So you'll get an email from Western Water Assessment with the link to the video. So any more questions, please feel free to send them in the Q&A box. It looks like we just got a couple more. So another question is, thoughts on using PVC versus wood to make the snow stakes?
Keith Musselman at CU Boulder actually mentioned that to us when we showed him a draft of the handbook. I haven't experimented with it myself, but these are all good things to do. And if anyone does try using staff gauges, understanding how readable they are and from what distance, or the PVC method, we would definitely love to collect feedback on that and share it with the community.
All right. Sorry, I'm just trying to read these. I think it's a comment rather, but one other option is to develop a protocol for the GLOBE program so that schools can get involved. Do you have thoughts on that, guys?
I'm not familiar with the GLOBE program, but I'll jot it down and I'm interested to look it up.
All right. Well, as of right now, I don't see any more questions. I'll give you maybe another minute or so to send any questions, and otherwise I think we can end early today. Oh, here's another question. Is there any encouragement for sites to pool data?
Is Marcos still on the call? I know he had to go and lead another webinar.
I'm still here.
Yeah,
I can take that. Yeah, in terms of building out a network, we certainly see the value of collecting the data essentially in a centralized database for those that wish to share and then learn across sites. I would say that's 2.0 of this effort, and but we certainly see the value of that. And if we were to build a network, that would be part of it.
And I guess I would just add from the dwarf perspective, we're certainly talking with the other forest health collaboratives here and wanting to, they're interested in doing similar work. And there's also some other researchers like Gigi Richard with Fort Lewis, who already has some, she has a slightly different approach, but is taking snow depth photos and snow density measurements. And so I think there is a local push also to pool information and kind of help inform what happens on this landscape at a bigger scale beyond just the dwarf specific boundary.
All right, great. Well, I think that's all the questions that have come in. So I guess we'll be ending early today. So thank you all so much again for joining this webinar. And thanks again to all the wonderful presentations from all 6 of you. It was definitely very informative and a pleasure to watch. And remember, we'll also be posting a recording of our webinar on our website. And we'll also send out an email blast to everyone on this call with the link. And in the meantime, just please feel free to reach out to any of us on any of the emails on the slide you see in front of you if you want to keep the conversation going. Or you can email us at wwa@colorado.edu. Thanks everybody, and have a good rest of your day.
Thanks everyone for attending.